Hello everyone, we are discussing curvature of vector valued function. If we have a curve in this shape in a plane, also we have a curve, a straight line, also we have in 3 space. Curvature of the curve measures how sharply the curve bends or how quickly the curve changes its direction. These curves bends and changing its direction, while if we have a straight line, tangent does not changes. There is no change. Curvature of a straight line is 0. And if we look into 3 space curve, there are bends in this way. So curvature here denoted by Greek letter kappa, and it is given by rate of change of unit tangent vector. Rate of change of unit tangent vector. We have some formula for curvature. And curvature in terms of parameter s, it is given by this one. In terms of parameter t, we will use these two formula. And reciprocal of curvature is known as radius of curvature, denoted by rho. This formula 1 is applicable if the curve is parameterized in terms of arc length s. Formula 2, second and third are applicable for obtaining curvature in terms of general parameter. These formula second and third, if RT is a smooth vector valued function in 2 space or 3 space, then for each value of t at which t dash t and r double dash t exists, then the curvature k can be expressed by these formulas second and third. The cross product, this cross product defined for vectors in 3 space, and if vectors are given in 2 space, want to use this formula, we adding 0 at kth component, and then we will use this formula. So we can say curvature is a scalar measure of the rate of turning of the unit vector t or unit tangent vector. Now we have seen there is no bend in a straight line, so we have a necessary and sufficient condition for the curve to be straight line. For the curve to be straight line is that the curvature equals to 0 at all points of the curve if curve is straight line. So generally we can say curvature of straight line is 0. Also, if we have circle, then curvature of circle is reciprocal its radius k equals to 1 upon r. and curvature will vary according to this thing. Curvature will vary from point to point along the curve. Now we will use this formula accordingly our question, and we will solve some problems. Find the curvature for position vector is this one, t sin t, 3 sin t and 3 cos t. We differentiate with here t is the parameter, we differentiate with respect to t, we will obtain this one. Tangent vector dr dt upon magnitude of dr dt. So this is a dr dt r dash, so 1 3 cos t minus 3 sin t. We are using here bracket form, or we can write in unit vector form also. So this will be magnitude of this one is, this is 1 square 3 cos t 3 whole square, and similarly this one. After simplification we will obtain 1 upon root 10 3 upon root 10 cos t minus 3 upon, because this quantity gives us 3 square 9, so 9 plus 1 10 under root 10. So this and if we differentiate with respect to parameter t, then this is constant 0. Similarly this one, this is constant and cos t minus sin t differentiation, and sin t is cos t, and this is constant. Now magnitude of rt given by simplification square root 10, and magnitude of t dash t given by 3 by root 10. So curvature is given by this formula. Second, t dash t upon r dash t, magnitude of. So after simplification, after putting the value 3 upon square root 2 upon square root 2 gives us 3 upon 10. It will be constant. Now we have some practice question by using this 3 formula. Find the curvature for circular helix x equals to a cos t, y equals to a sin t, z equals to ct. T is the parameter. Curvature will be a upon square root of a square plus c square, that it will be again constant. This is a next question. You can solve easily. Circle of radius e centered at the origin r equals to a cos t I cap plus a sin t g cap. T lies between 0 to 2 pi. Parameterize this circle by arc length and find Ts and Ks. In a tangent, unit normal and curvature. And we are converting this S T to S. And we will use our formula accordingly. Then we will use TSNS and KS. These are the answers, and you can use previous formula and you can solve, obtain the solution. For the curve x equals to a 3t minus tq, y equals to a 3t square, z equals to a 3t plus tq. Find the curvature k. Here we will use formula 3 third. So we will calculate this cross product r dash r double dash I cap k cap g cap x dash y dash z dash x double dash y double dash z double dash. By calculating this one, I'm putting value here respectively, and use the formula r dash r double dash magnitude of r dash r double dash upon r dash whole cube. We will obtain curvature 1 upon 3a 1 plus t square whole square. And if you are facing some problem, difficulty, then you can comment and we will provide you all the solutions of these questions. Hopefully, you are understanding the curvature and some points regarding curvature. You can comment in our comment box. Thanks for watching.